Greece, can you hear me? Hello, Greece. No, Greece. Hello? Can you hear me in Greece? Either you can't hear me or you are ignoring me. Neither is good. Sorry that you will have to wait right now, but I think it's doesn't make sense to start when nobody's hearing. One more time, Greece, can you hear me? Obviously not. Well, great that we will be talking about Industry 4.0 and the interconnection of everything when it's not even working, that we bring my voice over to Greece, but we will see what Shari can do. That's always the good part, that I can now give it over to Shari and she has to solve it. Hello? Hello? Die sehen uns nicht mehr. Maybe now? Ja? Ja. Was allerdings ja eigentlich vorbildlich ist, ne? Nicht aufs Handy gucken.
Can you hear us now? Good.
Hello, Greece. Hello?
Okay, bye.
Perfect. Are we waiting for anybody else? Okay, well, as I just said a few seconds ago, great that we will be talking about Industry 4.0 and its significance, and it's still hard to set up a video conference over some countries, so maybe we will get a slight insight what potentials we have regarding Industry 4.0. Just a quick introduction regarding myself. I'm Christian Döller. I work at WZL and am head of the Department Innovation Management. And together with Shari and Matthias, we prepared this lecture where I will be talking about the significance, challenge, and impact of Industry 4.0. I'd like to start with the history of production management, so several years ago, and just a quick remark, whenever you have a question, please feel free to ask directly. It's always much nicer for the one giving the lecture if we can get into some questions. So what we see here is basically how we used to work in 1800, and so we see a usual workshop where somebody is adapting a certain piece in order to bring it into a product. And from there, I think what we can say that production has changed according and due to the different industrial revolutions that we encountered. Being it the interconnection of the whole shop floor, where we are now able to see how specific machines are running, how is the utilization of specific machines up to now, totally new logistic concepts that we are encountering. For example, the introduction of drones into the automotive assembly. So maybe when we look at the different industrial revolutions, when we are especially talking about the second industrial revolution, where we had the whole mass production phase, what was, from your point of view, the key impact that allowed us to have mass production? Henry Ford, and what was the specialty about his concept? Series production, okay, really good point. Nevertheless, what allowed us to have series production? The assembly belt on the one hand, but what was the real special thing was that we were able to produce interchangeable parts. So when you're looking at, for example, caps of a pencil, now you are able to place one cap on the other pencil due to the fact that we were able to measure and produce certain parts as at a stable quality. Before that, we had the golden age of automobile production. So when we are talking about assembly back in the day, we are talking about reworking, filing of parts until they fit. So there was no mass production because you had to adapt all your little parts until they were fitted into your product. You had basically no R&D, but rather a trial and error, and no systematic quality tests, and therefore no innovation that was really possible. Of course, some innovations were brought in, but in terms of the whole assembly line, we were on a rather one-piece production. We had Frederick Winslow Taylor, who brought in our scientific business management board and introduced several topics. And then, as you just said, the mass production introduced by Henry Ford. And what we see here is the basic key enabler for that is the total and complete interchangeability of parts. That made the assembly much easier because we were able to produce these parts at a constant quality, and we were able to use these parts at the same spot without having to rework everything. And therefore, we also had the possibility to standardize certain parts of our product in order to focus on the real innovative parts that we should adapt. So what was the main effect due to mass production? It was economies of scale. So the economies of scale were, on the one hand, based on a learning curve that I have. Of course, whenever I do something multiple times, I have the opportunity to learn how to optimize maybe my way of working, my movements, and so on. So with an increased number of units that I produce, of course, the cost per unit will sink just from the work hours that I put in. Also, we had, due to automation, several decreases in the cost. Of course, whenever I introduce a new kind of automation, sometimes I have an increase per cost because it always costs to implement my automation technologies, and therefore, though a steady decrease over the units produced, you will always see some increases over time. And also our technological progresses in terms of the optimization within our production led to a decrease of cost per unit. In total, what we can say, we had a decreasing cost per unit over time, and especially over the accumulated production volumes. When we are looking at our 4 industrial revolutions, we have basically 4 different indicators that radically increased due to the industrial revolution itself. So when you're looking at the first industrial revolution, which started about 1825, we are introducing steam engines and electricity, and therefore what you can see right here is the increase in gigawatt hours per year that were produced, for example, in Germany, which radically increased over the time and possibly is still increasing. When we're talking about rationalization, meaning the mass production, the splitting of head work and arm work for that matter, you can see that the average per capita income steadily increased as well over time. The next thing that we introduced was the informatization and therefore automation within the third industrial revolution. So we had a much higher profitability of our information storage. And now we are talking about digitization and the fourth industrial revolution. And whereas the first three industrial revolutions rather focused on optimizing the work on the shop floor, we are now pretty much talking about our overhead productivity in terms of whoever is not working on the shop floor, whatever we do, for example, within our indirect departments, may it be the writing and derivation of assembly plants and so on, or maybe even the whole innovation departments. We really want to, or we really think that digitization helps us to increase the productivity of such overheads and therefore make the whole departments and even the whole companies even more profitable and give them a further competitive advantage. So this is what we are talking about when we are talking about the fourth industrial revolution. And with every industrial revolution came certain societal trends and development. So when we had first industrial revolution, separation of mental and physical labor, introduction of R&D in companies, and the prosperity of everyone, Taylorism allowed standardized labor, time studies, and also labor standards. With Fordism, we had the whole mass consumption part. I think I pretty much went over this. Then came some kind of resource awareness. So when we are talking about the Toyota production system, it was the main idea to make everything as lean as possible, meaning making everything waste-free. You want to produce everything in a way where you'd have no waste in terms of time waste or maybe resource waste. With this came also the lean movement, focusing on quality standards, especially within the Toyota, sorry. Especially focusing on the quality standards, because when you talk about lean, waste-free also means bringing out a higher quality. And now, what are our societal trends right now where we come into the producing industry? What do you think are the main societal trends that affect us and maybe also our companies? Any ideas? What is the main trend that we have today? Okay.
Getting advantages out of collecting production data, using this data to make your processes more lean and more efficient.
Really good. One great part, the collection of data is one trend, and also the coming up of a huge mass of data. Furthermore, maybe further trends that we have in general in society. Any ideas? Oh, you are young. You still know that. For example, when we talk about, yes, demographic change, one further part, okay, really good. I like the part that you said everything is on demand, though from time to time, maybe we still are not thinking about even the possibility that on demand might be better. What I'm going for right now is actually sustainability as well. Maybe this was too obvious when we talk about Industry 4.0. The question is Industry 4.0 one answer to all of these things that we are just discussed about? On the one hand, the whole collection of data, okay, Industry 4.0 can use this data, I agree. When we talk about demographic change, maybe Industry 4.0 helps us to integrate respective people adequately into our daily work, one possibility. when we are talking about on-demand, I think the really interesting part is that we are always talking in this context about changing business models, which I will come to in a second. And closely connected to that is the whole part of sustainability. So maybe before we go into the impact Industry 4.0 had for us, I will maybe give you a little introduction regarding the definition of Industry 4.0 and then regarding what we actually expected when we talked about Industry 4.0. Well, I did not talk about Industry 4.0 in 2007, but there were some people in this house here that already talked about Industry 4.0 for that matter. So what was the main effect of Industry 4.0 initially when you look at playing chess? And the challenge and maybe the competitions that men and women had when they played chess against the computer, right? So before 1997, you had barely no computer that was beating any significant chess master. So experience and knowledge beats the whole computational system. In 1997, there was a big change in that because Deep Blue won against Garry Kasparov, the world champion. And what was the interesting part? It happened in 19 moves, so I don't know how well Garry Kasparov plays chess because I'm not quite a good chess player, but I guess it takes a lot to beat this guy. The really interesting part was that in 2005 they had a freestyle chess tournament, and the winners were two amateurs with 3 ordinary computers. So what does this show us? What do you think? What is the main message behind that? Any ideas from Greece? What is the message when you talk about the fact that now 2 amateurs like myself, well, I would be just 1 amateur, but if I had maybe 4 computers, what is the basic message when we are now talking about the fact that you can beat the tournament? Yes, please.
Well, it could be that handling those computers is very easy, and that even an amateur can use a sophisticated machine to win experts at the game.
Okay. I think really good comment on that. What I would like to add to your comment is that now maybe we have the possibility to, well, comparatively combinate 2 different worlds. So you have on the one hand the humongous power of a computer and maybe the experience and the guts of a human being who can, based on the experience that they have, also support the whole moves that they make with chess. So the main thing that we had with Industry 4.0, especially within production, was the whole part of collaboration productivity, meaning the coming together of a human side with the respective digital side and with computers or further robotics. When we first started talking about Industry 4.0 and the whole productivity by collaboration, meaning productivity because humans interact with humans, humans interact with machines, or machines interact with machines, we try to make up 4 different fields that shall help us to achieve this collaboration productivity. And we try to, because we like these kind of different Ordnungsrahmen. Ne? Was heißt denn das? We like these kind of frameworks in Germany very much, and I love frameworks as well. So we try to build a framework where you see on the one hand the software and the hardware components interacting, and on the other side the cyber and the physical parts to Industry 4.0. And what we said is that you need one single source of truth regarding your data. It needs the respective hardware with the processing speed. On the physical side, we need a new social behavior in terms of my whole cooperation, and also the physical systems need respective automations in terms of cognitive systems and maybe nowadays even artificial intelligence. So this was what we first started with, especially here in Aachen, as a framework for the increase of collaboration productivity. And about that time, we also started discussing about certain definitions of Industry 4.0. And one now updated definition is that Industry 4.0 is the real-time capability or is real-time capable, intelligent, horizontal and vertical interconnection of people, machines, objects, ICT systems for the dynamic control of complex systems. So basically we said connect everything with everything and you can control a complex system. Baseline to this definition. So you always say you have to integrate all different levels, for example, when you're talking about the company, but you also have to integrate your whole network, and then based on the data that you generate, you can respectively control your complex system. In order to evaluate how mature companies are with regard to their integration of Industry 4.0, we try to derive a so-called maturity index. When you're looking at Industry 3.0, we had computerization. So this is something that I think was already mentioned within the third industrial revolution. We had digital networking. And now with regard to Industry 4.0, we have 4 different steps. We have the visualization that is made possible through this interconnection. We have transparency. Based on this transparency, we have a prediction, and then also in the next step, an adaptability. So on the low step, we say what happens. We just know what happens, and then we can understand why something happens. So far, even this is hard. I mean, if you go into many companies, they cannot even tell you how many parts or how many variants of a screw they have within their system, because they have not plotted their data adequately. They have no nomenclature in order to name their data, and so on. So even this nowadays quite hard. All right, we just had our IT looking into the room, so I was getting nervous because that sometimes could get a little messy. Okay, so the understanding now, when I have when I have the visualization and see what happens, I can maybe derive first understandings in terms of interrelation. Why did something happen? And then the next thing is I can predict what will happen, and the highest possibility I can achieve from our point of view is that I have to, or that I can react automatically and have a self-optimizing system. Okay, so these are just the four stages that I can achieve with Industry 4.0, giving me different advantages, of course. In general, Industry 4.0 on each level needs certain enablers, meaning lean tools, easy to use technologies, also the host sensors and middleware. Middleware meaning that I have the possibility to access proprietary systems like a PLM system, ERP system, and so on, in order to derive the relevant data that I can connect in order to create the transparency, for example. And these different enablers that I now have, also with easy-to-use programming, because maybe I can use an app, but the whole programming and the understanding and bring it into a system so other people can use it isn't quite the same thing. So these enablers lead to the fact that I can create in a lean way also waste-free processes, meaning I can support the whole digital business processes, and I can also support my whole automation through technologies. Once again, leading to different utilities, or to the utility perspective, where I have an increase in value added on the one hand. I can have increased responsiveness because maybe I don't even have to wait until something happens because I already know due to the fact that I made a prediction model that something will happen. Of course, I can generate transparency, as I earlier said, and maybe I'll just give you a small story and a small anecdote out of one of our industry projects where we tried to generate transparency for one company because they had no common naming of their parts. They did not know how many screws they had within their system. They did not know how many different plates of metal they had. And the most interesting part was how they named their plates. So the first plate was named plate long. Okay, so I don't know what plate long means, but maybe it's a meter, maybe it's half a meter. Better was the second naming, it was plate longer. And this is no joke, the last plate's name was plate longer than long. So you can see maybe in cases of transparency, you cannot generate transparency with that. Also, what you can do when you have these enablers that I just mentioned, you have real-time decision making. Instead of having to plan, having to simulate what your actions will have an effect or what effects your actions will have, you can maybe get a decision proposal. And of course, you support the structural learning because the system gets what happened due to the decision I made with my system and can integrate it into the next steps. So this leads basically next to the waste-free processes also to a structural learning on a company level. So just as a small reminder, you have your different enablers that you have in order to create waste-free processes and also learning in order to have those different effects on your system. To give you some examples for the different levels of Industry 4.0. So for example, here, I think even downstairs in our building, we have one application where we have an auto ID tracking of material flows. So it's just about seeing what happens. Where is everything going? So you have the visualization of high resolution production information just by adding a GPS tag, for example. And we just support, or we can support, the production control. Not even making any interrelations, just giving somebody the possibility to see where certain parts are for a certain time. One example that I really like a lot is the one of Jaguar with their Land Rover windscreen. So what this windscreen does, the sensors, they detect on the one hand the situation of the vehicle, and by aid of Industry 4.0 and the cause-effect analysis, the windscreen can now guide the driver during a race, for example, and the head-up display shows us, you know, when you used to play Need for Speed 2010, where you had your ghost car driving in front of you. That's basically what happens in real life there. So you have the line within your windscreen that can show you how you should adapt your driving within a curve, for example. And this, you can see, is a cause-effect analysis on the one hand, and now we as humans, in terms of collaboration productivity, can make better decisions. Some examples that are rather not from the industrial view, maybe, but from your personal experience, well known. On the one hand, the whole weather forecast system. So what does it do? On the one hand, capturing the current weather data, forecasting it from the internet, also saving your location, and then giving you and other people warnings regarding the weather. So you see right there the predictions the system makes helps you to react as well. And the last one, maybe Google Assistant. I think we can pretty much talk about a self-optimizing system right there, because you have the possibility to really interact. You can make automatic calls, and probably one of the highest evolutions in terms of Industry 4.0 stages that I explained earlier. Now I introduced a little bit, or I introduced certain examples of Industry 4.0 and maybe going back to our whole industrial implementation of Industry 4.0. What is the key problem that we have today when you want to integrate measures, when you want to optimize a system whatsoever? The core problem is that, for example, also for engineers, the best thing or the thing that we like to do the most is waiting and searching. Either you wait for information or you look for some information in some system where you do not know where to find it. So you have certain so-called latencies. So on the one hand, I have latencies, meaning I have an event, and it takes a certain time until the event data is available to me. This is a data latency. Then I have to analyze the data, and it always takes some time until I can really say what is the cause and effect within the data that I found. So I have a certain analysis latency. Then I have to make a decision. That's the worst part, especially if you have some bosses that do not like to decide a lot, right? So you give them some possibilities they could do, and they don't really know how they should decide. So you have a decision latency. And the last thing is the implementation latency. So whenever you make a decision, you have to implement a certain measure, and only then you react after the implementation of the measure, you react to this event. The problem is when you're looking at the benefit of an adaptation, the faster the better, right? So when you're sick, you rather go to the doctor as quickly as possible. You don't wait 5 weeks. Well, some people do, especially men, because they don't like to go to doctors, and I don't like to go to doctors, so my wife always gives me hell because I tend to make a decision here after 5 weeks. Doesn't help most of the times, nevertheless still living. But especially for companies, you should decide as fast and quick and right as possible. And we really think that one key driver for this, of course, is Industry 4.0, because now we can have real-time capability of data. We have the possibility that we have huge amounts of data. Therefore, we can faster derive certain measures, right? You can maybe also derive the right measures, giving your boss or whatsoever a portfolio of decisions with respective effects and costs that this decision comes along with. And maybe one day you even have an automation of decisions. We will see. But this leads to the fact that all of these latencies, or at least to a certain degree, I'm able to drastically reduce the latencies, and therefore the benefit of my adaptation becomes even higher. So when you're even talking about maybe prediction systems in terms of predictive maintenance, you see the event did not even happen. You can react before a certain event becomes a reality, and therefore the benefit is even bigger. So I think you see where I'm going with. Now one could think that due to the fact that we are talking about Industry 4.0, that we already had great effects, because now all our decisions are made on time, are made in a better manner, and so on. Nevertheless, we see some, well, effects, especially in Germany, that lets us think that the effects of Industry 4.0 are not as high and good as we anticipated when we talked about the increase of overhead productivity. So, for example, if you talk about the increase of overhead productivity, as I did some slides earlier, you could think that maybe, for example, our BIP or GDP would go up drastically. Nevertheless, what we see from 2011 until 2017 only increased by 1.8%. So where did all the overhead productivity go? We don't know. Well, we think we know, but at least we didn't put it on the street and got a whole increase. Also, when we're looking about, for example, innovations, and you compare China to Germany, especially within the mechanical and plant engineering industry, where I think we are specifically proud of that we can support, or that we do a lot of machinery and plant engineering. You can see that the world machine sales from China are way higher than the ones from Germany, and also, as I just said, the innovation indices are bigger as well in China. They're increased. And maybe two small remarks from some really smart people. So on the one hand, Professor Schalmo, he said the problem is that nowadays product, process, and service innovations can be easily imitated, and they are no longer sufficient to differentiate our products. So this is one thing we have to address. Also, the fact is that the industry has invested a great deal, but has still not achieved the necessary increase in productivity. This is exactly what I tried to say when I said we were looking for a lot of potential of overhead productivity increase, but so far we could not find it. So the question is, what happened? Because even if you look at especially the utilization of our different systems, may it be cars, rail, urban traffic productivity, and so on, but especially our machine tools, we can see that the overall utilization of machine tools in Germany averages 34%. So though we have Industry 4.0, the whole steering and what so on of production networks, we have a utilization of 34%. You know what that means on the other hand? 66% waste. Because 66% of the potential that I could have now is just not used. Of course, I cannot achieve a utilization of 100%, but I mean, if we would achieve a utilization of maybe 60%, would be a great deal. So somehow we do not manage to get this. And regarding all the other overhead productivity part, especially for development, we make some false suggestions that lead to the fact that we focus on our overhead productivity on the wrong parts. So, for example, when you look at the false suggestion 1, it means that we thought that customers pay a surcharge, so a price premium, for an individual special variant, because they get some unique specimen or some unique products. Probably every one of you has one of these Nike Air shoes with some ID tags on them. Probably, maybe, not? I do. Okay, then I'm the only one who went into the trap. Nevertheless, so the fact is that we try to make up configurators, we try to build machines like Nike and Adidas that allow to make fully specified products. And the question is, do we really pay, or do we need a totally special product, or is individualization to a certain degree not enough? The same, for example, with the VW Golf. You have, I think, about 3 million different variants of a VW Golf. What does it tell us? On the one hand, somebody has to design 3 million configurations of a VW Golf. It also gives us a hint that maybe VW doesn't know what we want. And going with the false suggestion number 2, maybe we don't even know what we want. I think one of the most famous quotes in this context is by Henry Ford. If I had asked people what they wanted, they would have said faster horses. So the problem is that we as customers and as consumers most of the time cannot adequately communicate our requirements to a manufacturer of any good. And the question is, how can Industry 4.0 address, on the one hand, this false suggestion that we need 3 million VW variants? And maybe how can we address this suggestion that we just want faster horses? And I think one of the possibilities is on demand, which I will come to in a second. All of this overproduction in terms of wrong variants, in terms of less utilization, leads us to think that we need different, well, we call it always, we call it, no, I have it, we call it the 5 big turnarounds. Because we think due to the fact, for example, that we are producing so many variants, so many cars and so on, that this all leads to a unsustainability that we as humans cannot pay for anymore. So we have to think, how can we achieve turnarounds in these major areas in order to strengthen our sustainability? And we think digitalization is the key driver to do so. And one key driver or one possibility for that is on demand, for example. Meaning we have to design digital networks that kind of replaces our overcapacity with on demand. And it's possible in nearly all of these different areas. Of course, I will go in production and business models later on because I don't know a lot about food turnarounds. Okay. For us, the change from overcapacity from a transaction model towards on demand is what we call the subscription model. Well, we don't call it that because we invented the wording, but for some years now, or for some time now, we really focus on the fact, how can I, by aid of new business models, use the data and really increase customer value? So when you come from the different business models that we used to have and the productivity and the added value for the customer, we had first sale of machines. So I go to my customer, I say one machine, the customer operates this machine. One could also put on some on-demand services regarding spare parts, repairs, and so on. Then the next step is the service contract. Then next one is the operator model, meaning the manufacturer or the service provider operates the machine for the customer. And what you see right here is that this is a one-time thing. So I sell the machine one time and then I tell my customer, well, you bought my machine, do with it what you want, and maybe you come back in 10 years and buy another one. The interesting part is that we have a continuous integration of, or a increasing collaboration, I might rather say, of the manufacturer and the service provider. And the utmost regarding added value for our customer, we think, is the subscription model. Why is it so? The subscription model is based on the idea that I have a digitization of my machines and that I also have the machines that I have within or that I have running within the system, that they are connected, that I can gather the data. And due to the fact that I, as a manufacturer, probably know in a better way, due to the fact that I have the data from everybody, I can maybe make better decisions regarding on how to optimize the productivity for my customer. So the basic idea is, due to the subscription model, I have a continuous increase in production. Okay? How to do this and what this also means in some examples I will give in a second. So just the idea, we think, in order to address the overcapacity and turn it in a direction of on demand, we need to change our business models. One framework that we are working on right now, especially here in Aachen, is the so-called Internet of Production. The Internet of Production proposed a 3-cycle framework, meaning we have a so-called user cycle, we have a development cycle, a production cycle, And all of these 3 cycles are connected by 8 of this Internet of Production. Meaning I can, for example, when I'm looking at cars, I can better detect problems with my cars, with my machines that I have in the system when they are running. I mean, of course, I can always take best guesses when I'm developing a car on what might go wrong, but the real problems I get when I'm using the car. The problem is nowadays, this feedback often isn't given back into the development cycle. You might have heard of the favorite example of missing link between development and user cycle by Professor Shu, who once had to buy a BMW i3. Everybody knows the example? Well, some did not. So I will go into this. So he had to buy this i3 car, and then he said to the sales guy, the tires look really small and they don't really look sporty like a BMW car should look like. And the answer of the BMW sales guy was, yes, I know, every customer tells me that. So he asked, okay, what does it mean every customer? Well, 100%. The problem is that BMW does not really know of this problem. When you're also looking at VW, I think they have 30,000 sales offices for their cars, and they don't have really a direct connection to their customer. They go, or the main information lies with the sales guys because they get in touch with the real customer like you and me. Okay, so I can detect problems within the user cycle way better than I can do within the development cycle. The thing is, within the development cycle, I always have to derive the evaluation of causes and failures. And within the production cycle, then I have to think about on how to release on a hardware side or on a software side, how to optimize the product. One possibility or maybe one example regarding a release or an adaptation over the air was probably Tesla when they had the hurricane in Florida, I think, when they all at one time had all further or bigger ranges of their cars. So this is just something that you could compare to an instant release. And we think that this framework, the Internet of Production, supports the fact that we can focus on the right product variants that we have to develop. And this then leads to the fact that we cut out the whole overcapacity part, and in combination with other business models like on-demand or maybe subscription models, this really is one sustainability driver. What I would like to do now is to go into each and every cycle and give you one or two examples per cycle where we think that there's a shifting in paradigm due to the Internet of Production. The first one is new business models. I briefly went into this already. I will go a little bit deeper into it now. So we are talking from a transaction to subscription. And the other one is a new customer understanding through data and maybe also through new methodologies like user stories. The most, or one of the most famous businesses that rather support the whole subscription idea is probably Netflix. So I will try it again, not with the shoes, but with Netflix. Do you also have all Netflix in Greece? Yes. Everybody got Netflix, right? Okay. So this is a perfect example, really, of a subscription model. So back in the day, Blockbuster Video, you were able to borrow some DVDs, and you had to bring them back. When you were a little bit late, it cost a whole lot of money. So the basic idea of Netflix was to give you access to the entire film database. You have continuous offerings. You have an individualization of the proposals and some flexible financing. I would like to highlight two things for that matter. And these two things especially address the fact how Netflix, for example, puts us as customers in the middle of everything. What was, from your point of view, the main problem or the main impulse why we are going to Netflix instead of to Blockbusters to get a video or a DVD or a film? Any ideas? One thing in Greece, any further ideas? Okay, then. Okay, not?
Could you repeat the question, please?
We were just talking about the fact that Netflix really puts the user, meaning us, in the middle of their business model. And what is the reason that you and I and everybody here in this room is using Netflix instead of, for example, Blockbusters or some videotheque? Yes?
It's much easier and more comfortable for the user and for everybody to just stay at home and have Netflix on the TV and just choose every movie that he wants, rather than going to the store, finding what movies he has, and then having to purchase and go all the way back home, and then having to return it back. It's much more
Yes,
comfortable.
thank you. Exactly. And we had one further? Point one, and I would like to add to that, you don't have to pay any late fees. So you have kind of you can plan how much you spend, and based on this, the rest is kind of free. So I think what they addressed is the one thing that we are all lazy and don't want to leave our houses anymore, maybe. And the other thing is that they tackled the key part regarding the money. We have now the possibility to plan how much you will be spending, and you will not have any deviation of the spendings. So I think this is these are the great advantages that Netflix offers. I mean, further subscription models you see is, for example, Spotify. I will not go into this anymore. Maybe Adobe Software Solutions, something really interesting because it has rather an industrial or B2B component to it. Looking into the producing industry, the key or one player that really does it publicly here in Germany with the whole subscription model is the company Heidelberg. You all probably know the company Heidelberger. They were in a lot of financial problems a few years ago, and especially looking at the printing industry, of course, due to the fact that we have less newspapers and so on, you had some alarm signs within the printing industry. And also, Heidelberg, they had a lot of problems, as I just mentioned, sorry. And their basic problem was that they had only one transaction per machine. And two problems arose with that. On the one hand, you only had one time cash flow. And the second thing is that they did not really know what their customer wanted. And on the other hand, they had this big opportunity because when they started selling machines they did not start selling the machines then, but in 2000, they started selling machines with a telecommunication cable or telecommunication contract to allow the maintenance via phone and so on. So they are sitting on a humongous data asset that they so far did not use. And now they know and they can benchmark how good are you running your machine. So the printer who uses the machine sends data to Heidelberg all the time, and they can now evaluate, due to the fact that they have 11,000 machines connected, that maybe printer A runs it at false parameters. Maybe the color they are adding is not the right one. And based on this, they can evaluate, or they can estimate on the one hand for how much money does the printer run get one sheet right now. And based on their data, they can also estimate for how much they could print it at this print shop. And what they are doing right now, they're going to this printer and telling them, let me tell you something, you are printing for 10 cents. I know you could print for 5. When you do the subscription business model with me, I guarantee you, you will print for 7.5 cents. So the effect of it is, on the one hand, I have a personalized service really cut to my needs due to the fact that they analyze what I'm paying per sheet right now. Also, I don't have a business model where only one profits. They are really open about the fact for how much they could print, and they are really open about the fact that they know for how much the printer prints. And now they are going rather into a collaborative business model where everybody has his or her win-win situation. And this is just one idea of how subscription business can work within the industry. And there you also focus, as does Netflix, on the real thing the printer wants. He doesn't want a machine. He wants a printed sheet. Okay. Also, if you're looking at Rolls-Royce turbine, they don't want a turbine, they want they want kind of power for the machine. Oh, bless you. Maybe you should go to the doctor, just, the event and don't wait 5 weeks. Also, for example, company Weiland, a company here from this area, they are selling different heating boilers and so on, and they are now selling warms instead of the heating itself. And Käser, which do compressors, they sell compressed air. And what I really find interesting about this fact is, for example, that you can much better standardize your products. Because if I tell you I will give you some warmth for your house, you wouldn't even care on how I would realize it. So instead of you configuring whatsoever of what you think you will need but you maybe don't, right? You now get your just the warmth for your house, and you get out of bed and it's all nice heated. And if you talk to some guys from Weiland and you ask them how do they derive their product variants and for which application area is their product variant, it's really hard to tell because they don't have the data flow and cannot really so far know which variants they have. So you have a real driver for standardization and really can focus on the customer value, and therefore what we think also address the whole overcapacity part, especially within your configuration space. What we need for that is the so-called digital shadow. The digital shadow is not the same as the digital twin. We always say that it is more condensed. So the data is more condensed, meaning we only want the relevant information. So if we are looking at my hand, I hope everybody can see my hand, you would not have to, you wouldn't need to see my hand as a whole to tell that this is a hand, right? So if I put it in front of the wall and I just have the shadow, of course there's less information because you wouldn't see my ring, or you wouldn't see that I probably have some dirt under my nails whatsoever, but you would still be able to see that this is a hand, okay? So we talk about the digital shadow being a more condensed information basis than the digital twin, but we still can extract all the relevant information, okay? This leads to the fact that we can process the data faster because we don't have as much data in the digital shadow, and therefore be faster with our decisions. And how can we really use this now for our subscription models? We have the digital shadow of the machines. We can now analyze our cost-effect relationships, meaning, well, kind of the second step within our Industry 4.0 maturity index, and now can really derive the right measures and also maybe directly implement them, right? So you need, on the one hand, the business model that allows you to gather the data from your customer, but you also need the possibility to analyze the data that you gather. This is from Heidelberg one example that they showed where you see the overall equipment effectiveness in comparison to the number of sheets printed per job. And what they can now do really is, due to the fact that they have the connected machines, they can make comparisons and tell you other companies with this number of sheets per job have this overall equipment efficiency. This is one thing. Also, they can now derive the customer needs in a totally new, different way. For example, their newest and proudest development was that they were able to bring out a machine that was able to print 18,000 sheets per hour. No, per minute. So 18,000 sheets per minute is like driving 300 kilometers per hour on a car, with a car. And now they looked into the data, and what did they find out? Nobody was driving 300. They were barely driving 120. Meaning that you have the problem that you try to develop some features in the best possible way in order of what you think your customer wants, right? So in terms of our sustainability and the waste that we generated due to the fact that they are only printing, I think, up to 15,000 sheets per minute, you have a lot of waste created, and due to the fact that we now have our Internet of Production, we can maybe derive for future developments the real innovation potentials that the customer really needs. Because it came out that the key was they were going for continuously smaller lot sizes. And the main driver of innovation for the customer is that they can switch quickly. And it's not that they can print quickly. Okay? Now, after the generation of basic data and how we can use the data on the one hand in a business model, I would now like to go into the development cycle, meaning how can we come from specifications and whole specification sheets to user stories that really also focus on the customer need, and how can we come from product variants to, we call it, I made a typing mistake here, sorry. How can we come to decisive splices of my product portfolio that really address a certain group of people that use the product? What this really is, I will come to in a second. So we always, when we start development, and when I talk about development as somebody who does innovation management for a living, and when you talk about to companies and tell them, just tell me the basic specifications your customer wants to choose when they get your product. You probably get a list this long. Even I, as an engineer, do not know what this is. And you do not know, for example, when you're talking about heaters, what this specification really does. So we had a discussion with one from the heating industry, and they were telling me, okay, you have some delay in water come through of so and so many seconds. I was like, okay, but I don't care. I just want to go into the bathroom and I want to have warm water. That's my use case. Me, Christian Döller, I want to get up, I want to go in the bathroom, I don't want to wait for warm water. Give me some product for that. I don't care how you do it. So you see, again, there we try to put the user into the center. Just as Henry Ford, who said, I cannot even ask my customer, you cannot ask me how much acceleration my car needs. I just want to have fun, right? Having a song in mind right now, but so we try to do this by aid of the user story, meaning we try to have a vision of a possible product, and then we describe the user on the one hand, who uses the car, for example, and in which context does somebody use the car. Along the development process, it's really important that you stick to your basic vision. Of course, you try now within a rather agile product development to generate prototypes that are tested, that you get feedback for, right? And you try to prioritize the functions that everybody's putting in, but you need to stick to your basic vision. And what you have to do really is to falsify or verify your key hypothesis. Meaning, for example, if we want to make a slight blink at Ego, the car we were developing here in this ecosystem, the basic idea was we want a car that is fun driving. And the question was, the key hypothesis was that the Bosch transmission, or the Bosch powertrain that we had, that this was a fun powertrain, or that this powertrain generated enough fun for the customer. Nevertheless, the powertrain was quite small. So how can you evaluate whether this powertrain leads to a fun car? And this is why you have to really falsify or verify your key hypothesis, for example, by aid of respective prototypes that are just there to really make a resemblance of the product, of your development status, without needing everything. You don't need the whole, chassis or whatsoever. You just need everything, so you can put a powertrain in something with 4 wheels and see with about the weight that the final product will have, is it still fun to drive, right? So this regarding the key hypothesis, and maybe also regarding our user story and the description of the user on the one hand, and also the use. If you, for example, do this for the users that we are looking at with the Ego Live, the small electric vehicle, you can say, for example, looking at somebody who does the whole care, who is in the care industry and drives to different, maybe senior citizens or different retirement centers, you can now go along the way or along the day of such a person. So maybe you depart your house and drive to the first retirement home. Then it takes about 1 kilometer until you get there. Then you go to the next household, 3 kilometers, and so on, and you go through all through the whole day, and therefore you get some decisive specifications of use. For example, the traveling time, how many minutes, how many minutes a day are you traveling, how many minutes a day is the car waiting, what is the distance, how many starts do you have per day, and so on. And based on this, you can also see that maybe some of the assumptions that we have about electric cars, that they need a range of 300 kilometers, might not be necessary for specific use cases. Because if they only drive 57 kilometers a day, why you need 300 kilometers of battery? And for example, I don't know how far you drive to get here as your student researcher's job, but my way to work is about 5 kilometers. So it's 10 kilometers a day that I drive, meaning 50 kilometers a week. On the weekends, maybe a little bit more. So 80 a week. What do I need 300 kilometers for? So everything that I do with my car so far, it's total waste. In terms of sustainability on the one end, of course, but also in terms of how are the specifications of the car. Right? So you get some basic specifications from this, but also you try to describe your user to see what they are really looking for in a car. For example, as someone who does the whole care sector, you want some reliability, you want maybe privacy also, you want the usability, due to the fact that you are driving around, you have to get out all of the time, and out of this you can derive the basic specifications for the product. What one should do, or what one can do, is also see if you have different user groups, what is then their product variant that they need. And I really, really love this example, because that's for me the worst part of variant management ever done. TV production. So now, or how we would like it to be, whether being it a car or whatsoever, we want, different groups of people that probably have the same requirements regarding a TV. Okay. I told the story already this week, but I will tell it again today. I tried to buy a TV now for 2 years. My wife gave me a budget, so I can buy a TV. Well, I can buy, of course. I am allowed to buy a TV. I don't know which one. Have you ever looked into the Samsung portfolio? There's so many. What the hell, I know which TV do I need. I want 65-inch, that's it, and give me something where I can plug something in, and I don't care how, I don't need 3 or 4 or 5 HDMI inputs, right? And probably half of you don't need it. But as if one would derive such a portfolio based on several variant groups that are based on the user stories, you can decisively say what is the differentiating factor of this TV. What does, for example, a business TV need, right? A stable, for example, wireless connection, something my TV in my office does not do because I get kicked out all the time, right? And then you can really make differentiating factors per variant group, okay? Living room TV, something like that I need, but that's about as much as I care about what the TV has, resolution and screen size. Maybe there are further TVs in terms of kitchen TV or bedroom TV whatsoever. So you see, based on the different users that we described by aid of the use and the user story, we could even lower the whole configuration space to just a few different variants per variant group, and we wouldn't have a lot of development waste in terms of the whole effort we have to put in to make everything work, right? So we have then a use-oriented definition of our variant groups. I hope the one thing just you should get out of the development cycle is the part of the user stories and the derivation maybe also of the key specifications that lead to your different variant groups or your splices of your portfolio in the beginning. And now we're going to the production cycle, where we basically focus on the one hand on the that we go from a sequential development to collaboration of product and production and product development. Because nowadays doesn't work as much. You usually have your engineers, developing something, and then you have your production managers like Shari that has to deal with everything that we engineers or that we from the development department thought of, right? And also the possibility to really change in an agile manner the requirements or to integrate the requirements that we get from the user cycle, right? So how does it go in a traditional way when we do product and process development? For example, traditional product development, VDI, VDI 2221, one of the most used development processes, as well as, for example, the stage gate process. And the traditional way always suggests that I first develop a product, and then, of course, I think of design for manufacturing, design for assembly, and so on. but rather in a sequential way, right? Just within the development phase. What I tried first to optimize the whole development process was a rather concurrent engineering, where I, for example, tried to, in a parallel way, develop the whole electric software and mechanics part, right? And the question is, why can't we try to also integrate the whole process development into our product development process? Because we would have two basic um, basic advantages of that. When I have an agile or highly iterative product development, due to the fact that I do a kind of parallelization between product and process development, of course I have an increase in speed. Maybe it takes in total, or if I would just look singularly at one, it takes a little bit longer, but the total time will be shorter due to the integration. So I have a much shorter time to market. The even more important part, I think, is the reduction of costs in several ways. On the one hand, I can directly develop a product in a way that it can be produced in the most efficient and productive way. On the other hand, I do not need to make great iterations which cost on the one hand time and on the other hand money. Meaning an iteration when I, as an engineer or a developer, do something in my CAD program which looks really nice, and then I give it to Shari and she says, what did you do there, Christian? Then we have to do it all over again. If you do it in a common way, in a real integrated way between production and development, it helps you pretty much to cut out such iterations, which most of the time, even then, after you make the adaptation to the respective part of your product, you then would have to adapt further parts, you then would have to adapt further production processes, really increasing the whole volume of the money-wise. So we need an optimal interaction in terms of producibility and customer focus, optimal interaction by aid of parallelization and also collaboration of development of procedures and products. The last paradigm that we would like to go into today is the whole part of our agile change requests. You remember the little car anecdote I told you earlier regarding the tires? What we think about when we are talking about an agile development is the possibility to really integrate our customer feedback along the process. Perfect, well, maybe not perfect, but one example is our Ego Live development. First of all, if you look at the first concept, right, you see how the design looked there. Then also you or you cannot see it here, but it is a fact that, for example, the dimensions were much smaller and you wanted to go into a different class of vehicle, right? And then we got several feedbacks along the way. On the one hand, we saw that we couldn't achieve the weight restrictions necessary. So we went from steel to aluminum. Furthermore, we got to know that our customer doesn't see our car as we designed it as safe as we thought it should be. So if a customer tells you it's a nice car, but I don't think it's safe, you probably think about it twice whether you want to go on with your idea because you've thought of it in the beginning, or you rather do a change that you have a real car that is bought by the customer. So you had the change from L7E to M1 car. And the last change that was made was from low voltage to high voltage due to the fact that the driving fun wasn't as much. And this is one idea along the development process, of course, which impacts a lot, nevertheless, the whole production side. So when you go from low voltage to high voltage, you need a whole different training. You need a whole different setup of your production sites, and therefore you need the possibility or the ability of your production to adequately adjust. What we also think is the integration of further tools along this process when we're talking about agile change requests. So for example, if you have your initial situation being it here the L7E category of the car, and now you get the feedback from your customer, we don't want an L7E car, we want M1. What we nowadays or back in the days did not know, what happens if I change that? There's no way. I mean, we talked about the whole transparency part of different planks, where nowadays most of the companies do not know which effects does it have if I make the car wider, longer, and so on. So we need fast feedback based on our single source of truth, being the PLM system that has all the data integrated. We also now have the possibility, due to different tools that we use, that you can adapt in a better way your work plan, and within production even get directly from your CAD model into the assembly line respective information for the worker who has to assemble the car. So these are just some drivers for agile change requests that were used at EGO. So regarding the paradigms that I wanted to bring to you today, and this is basically the key slide for that, we think that we need new business models to really make use of the potentials of Industry 4.0 with the customer centricity, with the usage of data, in order to increase the utilization on the one hand and to cut out all the waste that we create nowadays. And most of the waste that we create, for example, within the VW example, why do they do 3 million variants? I said earlier, because they don't know what we want, and because they don't know, and we don't know what we want. But the most important thing is why they do it, because they can. Because they are able to somehow manage it, and they have enough resources to put them on the derivation of so many variants, right? But the question is, do I really need to focus my workforce on 3 million variants, or are 8 enough for all my variant groups or my user groups, and I can focus the rest on real innovation? We talked about the fact that new customer of understanding through data is necessary and possible. Thinking about the Heidelberg example, we have to cut or maybe step away from our whole specification part and rather go into our user story thinking, which puts the user, meaning us, in the middle. And based on this, we can really derive our product splices that really fit the needs of specific customers. Another fun fact, anybody of you ever tried to configure maybe some German car? How long did it take you? Okay. Which car was it? Okay. Okay. Everybody, anyone tried it with Tesla? Try it. Takes 2 minutes. Yeah. So, and I tried both, not a Porsche. I'm not going that far, but so if you try to configure one of these cars, it takes 2 hours, and you are really devastated and frustrated after, well, at least I'm easily frustrated after 5 minutes. And if you go to the Tesla, you have 3 options you can choose, and I wasn't even getting the idea that I wasn't as satisfied with my choices, because the thing is why we have so many choices, because all of the manufacturers think that it makes us happy to have them. But As a matter of fact, being ready in 2 minutes and have a car was pretty cool. So I'm not a Tesla sales guy, but if you have 5 minutes from time to time, just try it. You will feel as satisfied as doing a 2-hour Porsche 911 configuration. Maybe, maybe not. Okay, but talking about the product splices, then the change from a sequential development towards collaboration of production and product, and also our agile change requests. How is this possible? Probably everybody, has everybody seen this slide? Schon 1000 Mal, okay. Everybody, you already also know this slide? Okay. No? This really tries to depict our framework or our model for the Internet of Production. You see here our different development cycle, our different cycles: development cycle, production cycle, utilization or user cycle, and you see that we still have our different raw data that we are using with the different application software, being it PLM, CAD, FEM, and so on. The real important part is the provision of and access to data with towards our middleware plus. So we have to manage the data access to the different systems, because then we can aggregate in terms of our digital shadow, we can aggregate our data, analyze it, and then make it accessible for the different users. So making it possible to fastly derive decision support for a developer, for somebody at sales, or for someone within production. This can then be supported, for example, by different applications that we use. We developed several of them over there in the demonstration factory from different views. On the one hand, for example, a weight management app, which just shows you how heavy your car is, which wasn't easy at first, really. Our MPM link, where you have the transition between the engineering BOM and your manufacturing BOM, or for example, pipeline monitoring, meaning how many people go into the configurator and configure a car and maybe buy it or not buy it in the end. And based on this, you see, you do not need all of the data in the system, but just specific information that needs to be aggregated and shown here. Maybe also some rather funny part to the, can we hear this? No, no? Then it's not funny. Okay, you can watch this video afterwards. IBM Watson and the interaction regarding collaboration productivity that can be used. I would like now to give you a little outlook on how we want to support the whole new way of developing and the new development process. This is quite a new initiative here on RWTH Aachen campus called the Innovation Factory. And what we want to support is really much the agile development process that I try to introduce to you with the user story, for example, and rethink that in order to support the whole new business model development, the whole part of generating data and analyzing it, that we really need to develop in a totally new way. And this new way is depicted here on the campus, that we want to integrate the different experts from different areas into our development projects in order to have complementary competencies that work on the same project. We tried to do this, or we tried to do that by aid of a respective development process that we derived, meaning we really want to generate ideas. We support the ideation phase. We put the customer in the focus, or we focus the customer. We want to do an agile development in a way that I focus on the development of specific prototypes in order to validate my key hypothesis by aid of the prototypes. And one further way is also the whole industrialization part. With this, we already are conducting projects, and one specific project I just want to give a little impression of how this works was when we had a customer asking us whether we could develop one charging point for them. And it was really an interesting discussion. We were with these guys at the dinner, and they were like, can you develop this for us in the first prototype? Being it as cheap as possible for them and as fast as possible. And I made a bet with this guy that we could do it in 3 months. Right before Christmas, I got an email from him, or it was right after Christmas, with 3 lines with the specifications. First of all, my wife got mad that I was reading emails between Christmas and New Year's, but nevertheless, I answered him that we are now starting the development right after New Year's. And it was really interesting because based on just these 3 different specifications we had, we tried to really derive our user stories. We went to different possible customers of them, derived the user stories in a way that I just showed you. And then, due to the fact that we were able to, on the one hand, integrate, for example, the eLab, we were able to integrate some colleagues of Shari and also the demonstration factory. Within just 3 months, we were developing a whole product, a functional prototype that they were showing to their sales manager or their whole sales boss. So what you can see there, due to the configuration of the competencies, we now want to support the development of new products in a cheaper and way faster way. In total, we want to also one day build a new cluster. I mean, you probably all heard about the concept of the RWTH Aachen campus. The innovation factory is kind of the door or the orchestrator to it all. And maybe just to give you some insights on how it might look. On the one hand, there will be some so-called shops where you can really get expertise regarding development, regarding the production of several parts. There will be prototyping labs and also so-called camps. The camps being just one bigger room with all the necessary prototyping equipment where, for example, a company could go in with a team of developers supported by us in order to develop such a charging point that I just mentioned, and also to support the whole part of collaboration. We want to generate the whole or integrate the whole convention part. This will be one day built on the Campus West, just to give a little outlook of the new ideas we are striving for here. So I just wanted to show you what we are trying to do here in this ecosystem in order to support all of the Industry 4.0 initiative, but also to support a new way of development in order to generate the respective customer value. Okay, coming to the end, maybe just a short summary of everything I showed you today. I think we need to think in a new way regarding innovations. We saw that the whole Industry 4.0 initiative makes great impact, but kind of we forgot to realize all the potentials that were possible and rather wasted the potentials on some aspects that we now were able to do, but didn't really lead to the customer value that we would be able to generate. I would like you to remember that the Internet of Production for us is one possibility to address and support our whole overcapacity and thus unsustainability problems that we have, especially within the producing industry, in order to go from a now known transaction business model towards a rather sustainable system we need to look at the user cycle, the development cycle, and the production cycle in order, on the one hand, to generate knowledge from the customers that we already have, to be able to use data to generate new business models, develop in a whole way, because now we know how the customer uses our product and we can specifically develop less variants for our customer groups, which are derived by 8 of user stories. And the last thing, we want to, or we need to, parallelize process and product development to save a lot of money, save a lot of time on the one hand, and also to be able, due to the fact that I now continuously maybe adapt my products, to generate or to realize agile change requests. And with this, I'm a little early. I hope you don't mind, because now you have the great opportunity to ask some questions. For so far, I first would like to thank you for your kind attention. I hope you were able to get something out of this lecture. As I said, if anybody has questions now or afterwards to any of these topics, please feel free to ask. No questions? Any questions? Yes?
Can some of these applications be used without the use of internet?
The Internet of Production?
Generally,
no, which applications do you mean?
Of Industry 4.0, Internet of Things includes Internet of Course, or big data, and etc., etc.
Well, I mean, of course, you can connect them in a separated network, probably. If it's then the internet or not, that therefore I'm not as much an IT specialist as I would need to be. But in general, I would say, of course, you can connect them in terms of private networks, but for me, the internet would be one key driver. Sufficient enough answer?
Yes, thank you.
Okay. Further questions? All right, then I wish you all a nice evening, and maybe I talk to you, no, not next year, but some other day. All right, thank you, bye.